Good morning all. Myself Mohammad Shafiullah, Assistant Professor in Department of CSE BITM Bellary. Welcome to this course on C programming for problem solving. In this video, I am going to explain you about a linear search program. So this is the problem: develop a program to search an element from a list of elements using a linear search technique. So what is searching? It is a process of finding an element or process of retrieving an element from an array of elements or from a list of elements. The element which we are interested to find is known as a key element or a target element. This is a searching process, right? And that element which we are interested to find, which we want to retrieve it or which we want to find it, we call that as a target, or we call it as a key element. So to search an element in a given array or a list of elements, we have two ways. One is called as a sequential search, which is called as a linear search. The other is an interval search, which is nothing but a binary search. So our focus for this session is about on linear search. So linear search is very simple and it's a basic searching algorithm. So in this technique, what we are going to do is we are just going to compare every element. We are going to compare with the every element, and we are trying to compare our key element with the element of the array. Every item here is checked, and if there is a match, what we will do, we will try to give that particular index as the position. Otherwise the search will continue. How long this search continues? Until the end of the data collection, until the end of the array. So what we are going to do here? Suppose if we have the key element, we'll compare the key element with the first element. If there is a match, fine, that's great. Take the position, that is retrieve the position. If not, try to compare with the second element, with your key element. If there is a match, then try to retrieve the position. If not, compare with the third, and so on. How long? Until you reach the end of the array. In case if your key element is if your key element is present in the list of the data, we call it as a search is successful. Otherwise, that is in case if you don't have the key element present in your list of elements, you call the search as unsuccessful. So what are the steps in linear search? Start, then read n, that is read the size of the array, and then initialize flag equals to 0. Flag is a variable which indicates your search operation. Initially we assume flag as 0 because we have not yet got the key element, right? So when do you say the key element is found or the search is successful? When your flag value changes to 1. That is when your flag variable changes to value 1. Initially search is unsuccessful, so flag is 0. Once your search is successful, make flag as 1. So read these array elements A, then read the key item to be searched. Now iterate from for loop for I equals to 1 till n. If your element of the array, if a of I is equals to key element, then print the element found at index I. Then initialize flag to 1 because we have got the key element. If not, we have to repeat this. How long? Till starting from 1 till n. If you got it, flag is 1. If you did not get, then search is unsuccessful. End if and for. Finally, compare your flag. If your flag is 0, you say print element not found. Then stop. So let us implement this linear search on this set of elements 5, 8, 0, 12, 4, 7. Let us assume our key element is 4. Fine, I have got 6 elements and my key element is 4. So what should this program should return? What this linear search should return? It should return me the position, that is search is successful. 4, that is our key element is found at position 5. So which is the key element to be searched? I have made it in bold red color to tell that it's a key element. So what are the variables? Array A, key to search the key element, I for looping, n is the size of the array, flag is a variable which is indicating our search operation. So now, in our case key element is 4, right? So the search begins from the first element of the array. As I said that it's a sequential search, right? Linear search or a sequential search. Sequential or linear. So what we are doing? Sequential, one after the other. Now compare your first element. Which is your first element? 5. It's at index 1. Is it your key element 4? No. What I have to do? Search continues with the second. Increment and then compare key element. Is it 8 equals to 4? No. Can you look at the green color? Is the one which I am comparing it at the right at the moment. Whether 8 equals 4? No. What I have to do? I have to compare again. What I have to do here? Again I have to compare this with 0. Whether 0 equals 4? No. Whether 12 equals 4? No. Whether 4 equals 4? Done. I got my key element. So search is successful and key element 4 is found at position 5. That is what this program is going to do. Let us assume that the key element here is 10. Let us assume that our key element is 10. So 5 is equals 10? No. 8 equals 10, 0 equals 10, 12 equals 10, 4 equals 10, 7 equals 10. No. I have reached the end of the array, right? So no question of finding the key element, because our key that is our key element 10 is not present in the list. Hence I say search is unsuccessful if that is the case. But in our case it is the key element is 4, wherein we say search is successful. If I had taken any other number which is not there in the list, it has to complete all the search operation until I reach the end of the list. Fine. So what are the advantages? Absolutely, it is very simple approach. But important thing is, yeah, it works for smaller arrays, and then it is used to search when the elements are not sorted. That is what we say. These are some advantages. That is, it is used to search when the elements are not sorted. That is, doesn't require a sorted array. But binary search technique requires a sorted array, which I am going to explain you in the next session. But this linear search doesn't require sorted order. It requires an unsorted order. So what are the disadvantages? It is less efficient if the array is large. Here we says that it works well for smaller arrays. It is less efficient if you have the size of the array to be large. And if all of the elements are already sorted, then linear search is not an efficient technique. Why it's not an efficient technique? Because there is one more counter technique called binary, which does it efficiently than linear search. So these are the drawbacks of it. And coming to this, why do we call this as an inefficient for the larger size? Because it is a time consuming. Fine. Let us assume in our case, if I have got 100 elements here, how many elements? 100 elements. And then my key element is my 100th element. Let us assume that the key element is the 100th element. So how many iterations it has taken? It has to take 100 iterations, right? So this is less efficient. And let me assume that I have an array, for example, an array of 200 elements, right? So, and the key element what I am searching is not there in the array itself. So how many iterations it has to take? It takes 200 iterations. It has to take 200 iterations. That is, it has to search, compare 200 times. And at the end of the array, it realizes that there is no key element present. So that is where we say this is not efficient. We say it is inefficient. So now coming to the program part of this. So this is the program to demonstrate linear search on list of elements. So we have a documentation section, preprocessor, directives, main function. Then we have a local declaration section wherein we declare our variables. A of 20 comma key I and flag equals to 0 initially indicates that the search operation is unsuccessful. Now enter the size of the array. This is normal till today. We have seen this. Enter the size of the array, wherein we store the size of the array in a variable n. Then this is the code to insert the elements into the array. For I equals to 1, I less than or equals to an I plus plus, scanf %d ampersand a of I, right? So the same thing. Now enter the key element to be searched. This is about entering the elements into the array. This code is to enter the key element, whatever the key you want to search. The program prints a message to the user, enter the key element to be searched. Now when you give any key element, that will be stored in a variable key. Now this code is to search the element, key element. This code is to search the key element. What it does here is, for I equals to 1, I less than or equals to num I plus plus. Your for loop begins here and your for loop ends here. Okay. So in each iteration, what you have to do, compare your array element with your key element. If a of I is equals to key, in case if your key element is found, suppose if your key element and a of I are equal, what I have to print? Search is successful, %d is present at location %d. That is, search is successful, 4 is present at location 5 or something in that way. So this is how it goes. Once you realize that search is successful, you had assumed flag value as 0 here, change it to 1, indicating that search is successful, key element is found. Then apply break. Why you have to apply break? Because you are in a for loop. To terminate that loop, the moment you got the key element, no question of progressing further into the array. So exit from the for loop. So where for loop ends, it ends here, right? In case if your key element is not found, this part will not execute. Remember, this part will execute if is going to execute if and only if you have a match found. If there is no match, this is not going to execute, right? In our case, I value, when I value is 5, because our key element is at location 5, right? So in our case, at when I value is 5, we say that key element is found. For if A of 1, for 1 when I value is 1, this is not going to execute, if will not execute. For I equals to 2 also it doesn't execute, 3, 4. But when the moment I value is 5, A of 5, what is your A of 5? It is 4. What is your key element? 4. Is it a match? Yes. So what it does? Search successful, 4 is present at location 5. This is what we are going to get. Flag becomes 1, then break. The moment you apply break, it terminates the loop. Remember, it terminates a loop. Break is a keyword which terminates a loop. Finally, this code is to take care whether there is no search, if the search operation is unsuccessful. But in our case, flag value is not 0, right? We have changed to 1. So this part will not execute. This part is going to execute if and only if you don't have a key element. So finally terminate the program. So let us assume that, as I said, that let me find 10, right? In our case, in this case, let me assume that I want to find the key element 10. What happens here? I starts from 1 until up to 6 it goes. Fine. Nowhere your flag value becomes 1, because this part has not at all executed. This part will execute provided there is a key element in your array. Since we don't have the key element 10 in the array, this part is not at all executed. So what happens? Your flag is same. What is that? 0. So when your flag value is 0, search unsuccessful, 10 is not present in the array. This is what I get the code. Fine. So let me run this code. I have the code here, same code, program to demonstrate linear search on the array of elements. So enter the size of the array. Let me give it as 5. I'll give it as any order, because linear search takes any order, right? 9, 8, 1, 7, 4. So I give it as 98752. Now it is asking me the key element to be searched. I give it as 5 here. So search is successful, 7 is present at location 3, right? So now once again I will run the program. So once again I will run the program and then give the values as 98750. Now let me give as 6 as the key element to be searched. Search is unsuccessful since 6 is not present in the array. Fine. So that's it for this session. Thank you.